Hello everyone, in today's video I'm going to show you how to solve this problem. So it says find the magnitude and direction of the resultant force on this block and hence the resultant acceleration of the block if it has a mass of 25 kilograms. In this problem we are given two forces, Fa equals 15 newtons and Fb equals 10 newtons, and both are concurrently acting on this block of mass m. However, each force is acting on this block at an angle such that Fa is acting at an angle of 35 degrees to the horizontal, whilst Fb acts at an angle of 110 degrees to the horizontal. So this is a concurrent force problem. Also, both forces are coplanar, meaning they are all acting through the same center of mass in their respective directions and also in the plane of the screen. So to solve this problem, we first need to define our coordinate system. We need to establish the XY axis, with the vertical axis being our Y axis and the horizontal axis being our X axis. Now, any force acting vertically upwards is going to be positive, whilst any force acting horizontally to the right is going to be positive. And we are placing the origin at this point. So in this physics problem, we will place the center of mass of the object, which is this block, at the origin. And then with that, we can represent it as a point particle and use arrows to represent each of the forces acting on this block. So let's draw the free body diagram for this problem. We draw our coordinate axis. So we have the vertical axis and then we have the horizontal axis. Now we are going to place our block at the origin, which is here. Then we can see that we have a force Fa of 15 newtons is acting on this block at an angle of 35 degrees to the horizontal. So this is the horizontal line, which is also called the reference line. We measure the angle counterclockwise. So from the positive x-axis, we measure the angle and then we have the force Fa in this direction. We represent it with an arrow and then label it as Fa. This force Fa makes an angle of theta, which is equal to 35 degrees to the horizontal. In the same sense, we have Fb, which is 10 newtons and making an angle of 110 degrees to the horizontal. So if we start from 0 here and we measure counterclockwise up to this vertical axis, we have 90 degrees, and then if we need 110, we need to go further 20 degrees so that we get 110, and that is where Fb is acting. So Fb is here and it makes an angle theta to the horizontal positive x-axis, okay? And this angle is 110 degrees. So we can see clearly these two forces are at an angle to the horizontal, so we need to resolve each of them to find the horizontal and vertical component of these forces. So we will review how to resolve a force or a vector into its components, right? So if you have any arbitrary vector, let's say vector A pointing in any direction here, let's say. So this vector has a tail, which is the origin, and then a head, right? That is where the length of that vector ends. Now, placing our coordinate axis, we can see clearly it makes an angle with the positive x-axis, right? So this is our x-axis and this is the y-axis. So this vector A makes an angle theta to the horizontal. From this, we can develop a right triangle because this vector A is going to have a component along this x-axis, which we can call AX. In the same sense, it's going to have a component along this vertical axis, but due to geometry, it is just same as here. So we call that vector AY, meaning the vertical component of A. Now we can see that we have a right triangle and we can apply trigonometry to determine AY and AX. So if this is the angle of interest, then we have the opposite side to be AY and then the adjacent to be AX. Therefore, if we do, AY is going to be the vector A and then sine of the angle theta. In the same sense, if we want AX, is going to be A cosine the angle theta. And we can always apply this to any vector, provided we measured the angle with respect to the positive x-axis in the counterclockwise direction. So we are going to apply these to FA and FB. So let's start with FA. So with FA, we have our axis with the origin or the center of mass of the block placed here. So we have FA, which is acting in this direction, and then it makes an angle theta A with the horizontal. So we can have FAX, and then the vertical component, we can have FAY. So applying this, we can get FAX to be equal to FA cosine of the angle theta A. So FA is given to us as 15 newtons and then cosine of 35 degrees. FAX should give us 12.29 newtons. All right. So if we do same for FAY, we get FA sine of theta A. All right. So FA, which is 15 newtons, times the sine of 35 degrees. And this is going to give us 8.60 newtons. So these are the horizontal and vertical component of FA acting on this block. And we need to do same for FB. So for FB, we have FB acting at an angle of 110 degrees. So, and then we have FB. All right. So this is theta B. So in the same sense, FBX is going to be FB cosine theta B. But FB is 10 newtons and then cosine of 110 degrees. FBX will be equal to negative 3.42 newtons. And then we find FBY, which is also FB sine of theta B. And that is going to give us 10 newtons sine of 110 degrees. And that is going to be equal to 9.40 newtons. So applying this force resolution using AY, that is the component in the vertical direction, as A sine theta and AX as A cosine theta, we are able to resolve each of these forces, FA and FB, into its respective X and Y components. Now we need to find the resultant force. And in finding that, we need to add all the X components from both FA and FB, and the same way we need to add all the Y component from both FA and FB. So let's see how to do that. So the resultant, let's call it R, is going to be equal to the sum of all the forces along X plus the sum of all the forces along Y. So for Rx, that is the sum of all the Fx forces is going to be Fax plus Fbx. And then Ry is going to be the sum of all the Fy forces, which is Fay plus Fby. But we already found these, so we can just plug them in here and then determine Rx and Ry. Fax is 12.29 newtons plus Fbx, which is minus 3.42 newtons. So if we add these two, we are going to have 8.87 newtons. Okay. In the same way, we already found Fay and Fby, so we need to add them to get the resultant y direction forces. Okay, so in that case, we have Fay to be 8.60 newtons, all right, plus Fby, which is 9.40 newtons, and that is going to give us about 18.00 newtons. Now we can visualize this to see, because we know Rx, we know Ry. So if we go back to our coordinates system, we can see that Rx has to be along the x direction and Ry has to be along the y direction. So if we place the center of mass of this block here at the origin, Rx, which is 8.87, is going to be along the x direction. So let's say this is 8.87 newtons. That is our Rx. Okay, and then our Ry is going to be along the y direction, which is 18.00 newtons. Now we can see that the resultant is going to lie in this, maybe more to the y axis because that is a larger force. And now we can see we can develop a right triangle with the resultant being this force, right? And it makes an angle theta r with the horizontal or the positive x-axis, okay? So this is how this is going to be. So the resultant is going to be in this direction. So the task is to find the magnitude and the direction. You may have heard about equilibrant force. That is the force needed to balance this resultant force. It's always negative of the resultant force and it is going to point in the opposite direction, okay? And that is our equilibrant force. But we are not looking at that today. What we are doing is to find the resultant force and its direction. So since we have a right triangle, we can apply the Pythagorean theorem, which says that the resultant force squared should be equal to Rx squared plus Ry squared. Therefore, the resultant force is going to be the square roots of Rx squared. We know Rx, so we have 8.87 newtons squared plus Ry squared, which is 18.00 Newton squared. So evaluating this should give us a resultant force of about 20.1 newtons. All right. So that is the magnitude of this resultant force, which is R, and we've seen it's pointing in this direction. Okay. Now we need to find this direction, theta R. And to find the direction, since we know Ry, we know Rx, we can apply the tangent. So the tangent is going to be tangent of theta R. That's the direction for the resultant force is going to be Ry divided by Rx. So the angle theta R, we need that, so we have to take the inverse tan of Ry divided by Rx. So if we do that, we have theta r to be inverse tangent of Ry, which is 18.00 divided by Rx, which is 8.87. So the newtons cancel out to 1. So if we do that, we are going to get an angle of 63.6 degrees. So theta r, the direction of this resultant force is going to be 63.6 degrees. All right. So we found the resultant force and then we found the direction of this resultant force. However, this is not the end. We can see that the problem says we should find the resultant acceleration of the block if it has a mass of 25 kilograms. So for the direction of the acceleration, we know that from Newton's second law, it says that the net force is always equal to the mass of the object times the acceleration of the object. And this net force is what we just calculated on the block as the resultant force. So it's going to be R equals ma. So these are vectors. So a vector, that is the acceleration, is going to be the net force, which is the resultant, the magnitude of the resultant divided by the mass. So if we know the resultant to be 20.1 newtons divided by the mass given to us as 25 kilograms, then the acceleration is going to be about 0.80 meters per second squared. However, from Newton's second law, we know that the net force produces an acceleration in the direction of the net force. So therefore, the direction of the acceleration is going to be the same as the direction of the resultant force, and that is equal to 63.6 degrees. All right, so this brings us to the end of this problem. It is a good practice for how to resolve vectors into its component and also apply that in terms of physics to find the net force that is acting on an object, and hence the acceleration of the force and the direction of the net force, as well as the direction of the net acceleration. All right, if you are new to this channel and you found this very helpful, hit the thumb button so the algorithm can favor this video. Also, if you subscribe, you get to see more of such videos every week. And if you're already a subscriber, thank you very much for your support, and I'll see you in the next one. Bye-bye.